right, so we are looking at notes 3.2 if you are keeping track. And eventually we are going to get to the graphing, all right, piecewise functions. But we are also going to be finding domain and range. Domain and range. And it's going to be easier if we start with the domain and range, because then once you graph the piecewise functions, you're going to have to tell me the domain and range. Okay? All right, so let's just do a quick review of what domain and range are. All right, does anybody remember what domain and range are? All right, I bet if we did an example, you would remember. Okay, so leave some space, all right, for us to come back and do our definitions of domain and range. All right, but let's look at some review from Algebra 1 and see if it rings a bell. Okay, so all right, so we'll say Algebra 1 review. All right, find the domain and range. And I'll slide this up in a second. Find the domain and range. Now, you actually had to do other things with it when you were finding the domain and range, but this is all we're going to review right now. All right, and whoops, go away. There we go. Okay, so for my first example here, I want to give you a table of values. All right, so I'm going to give you some x values and some y values. -3, -1, 0, 2, 5. And then my y values, 7, 5, -1, -4, -2. All right? And then I want you to tell me your domain and your range. So one of those lists is your domain, and one of those lists is your range. Anything coming back to you yet? Nothing? All right, well, let me write it out. Well, that's kind of sloppy. All right, so your domain and range have proper notation. They're going to go in curly brackets. All right, and then I'm just going to list some numbers, and I want you to tell me where I got it from. All right, not sure what we're clicking on the computer, but if you don't mind, please set it aside. All right, where are those, where do you think I got the domain numbers from? The X column. Where does it look like I got the range values from? The Y column. Okay, anything starting to come back to you? The domain are the X values. The range are the Y values. All right, let me give you another example from Algebra 1. All right, sometimes you were given ordered pairs like this and asked to find the domain and range. Okay, so what do you think the domain is? What numbers? Thank you. Very good. And you just list them and put them in curly brackets. Very good. Because those are the x values of those ordered pairs. All right, so someone else tell me the range, please. 1, 7, 3, and -2. And I guess I could spend the time putting them in order, but I'm not even worried about that at this point, as long as you know it's the y values. Okay? So that's what you had to do with domain and range in Algebra 1. All right, so let's go back up and let's write a definition. Okay? So the most basic definition is that the domain are the what values? X values, and the range are the y values. Okay, but we're going to make it even more formal than that. All right, so the domain is the set, that's why it goes in curly brackets, the set of all x values, okay, that can be plugged into a function. All right, so that means we're not just going to be given like a bunch of ordered pairs. You might actually be given a function, whether it's a regular function or a piecewise function or whatever. Okay, so it's a set of all x values that can be plugged into a function and result in a real number. Okay? And we haven't talked about things that are not real numbers yet, but we will. Okay? All right, so that's our formal definition for a domain. Essentially, it's all the x values, right? But it's all the x values that are allowed in that function. All right, and so the range is going to be the set of all y values. Okay, now you have to understand that when you plug in an x value into a function, the answer is a y value. Okay, so the domain is the set of all y values that result, that you get, okay, that you get from plugging stuff in. All right, so that result from plugging in all possible x values in the domain. So it's a set of answers. It's the set of answers that you get when you plug in the domain, when you plug in the x values. Okay? All right, so what we're going to be doing is we're going to be finding the domain and range from a graph. Okay? That's what we're going to start with. We're going to be finding the domain and range from a graph. All right, finding domain and range from a graph. All right, so I want to talk about how you do it, and then we're going to actually do it. All right, so for the domain, all right, it's still definitely the x values. All right, x values. That you cannot forget. Okay? So then how do you get the x values from a graph? All right, well, you are going to read the graph from left to right, okay, to determine which x values are touched. You're going to read the graph from left to right, and you're going to look at what x values does the graph actually touch. Okay, and I'm not talking about individual single numbers, because our graphs are going to be lines and curves, and so you can't just list. It's not going to be a list of x values like the Algebra 1 stuff was. It's going to have to somehow be an integral or inequality that represents all the x's that you're touching. Okay? All right, and then the range, all right, well, those are still the y values. So to get the y values off of a graph, you're just going to read the graph from bottom to top. Okay, so from bottom to top to determine which y values have been touched. And touched is, you know, I guess a weird word to use here, but that's why I put it in quotes. Okay? All right, so take a second and finish copying that. Okay, so what I want us to do, all right, so we're getting into our examples, all right, you are going to determine the domain and range from the graph. So I need to give you a graph. Sorry. I know it's a lot of work, it's a lot of writing, all right, but once we take the notes, all right, the writing part is just the notes part. Like actually doing the work, all right, does not take a terribly long amount of time if you understand the concept. Okay, so I'm going to call this example 3, all right, and I'm going to give you a graph. Now, it's not going to be the prettiest thing in the world, but we'll put a couple marks on here so you can count, all right? And then I'm going to put a point down here at 0, -2. And I'm going to draw a U-shaped graph, which we haven't really talked about, all right? Those are called parabolas, all right? There's my graph. It's nice and smooth. Okay, so it's actually not broken into pieces. So even though we haven't gotten to the graphing piecewise, this is not a piecewise. It doesn't have several pieces to it. Okay? All right, so now I want to figure out the domain and range. And this is where the whole idea of reading the graph from left to right, all right, and bottom to top comes into play. Now, I want you to understand that we're actually going to do it in 2 notations because you need to be familiar with both. So we're going to do it in interval notation first, and then we're going to turn that into set notation. Okay, we're going to do interval notation first, and then we're going to turn that into set notation. Okay, now, let's talk about the graph for a minute. This graph has arrows on the end, right? You with me? All right, and the first thing I want you to understand is that the left arrow is pointing up, but it's also, even though it doesn't really look like it, it's getting wider and wider to the left as well, okay? And so the right one is also pointing up, but it's getting wider and wider and wider, right? So it just keeps going out, 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 okay? So when I'm looking for the domain, I'm really asking myself, how wide does this graph go, okay? That's what I'm looking at, from left to right, okay? Well, if it keeps getting wider and wider and wider, even though we can't see it, all right, what is the biggest number to the left that we can ever write? What's the biggest negative number we can come up with? What's the biggest positive number we could ever come up with? What was that? It's a symbol. It's not really a number. Infinity, yes. Okay. So infinity is the biggest number. We can't actually write a number for it. It's a symbol, right? That represents the biggest. Or if it's negative, it's really the smallest. Okay? So what I want you to understand is that, you know, our graph keeps going to the left forever out to negative infinity. And it keeps going to the right forever to positive infinity. Okay? So if I talk about where does this graph start, okay, from left to right, where would it start? What's the biggest number in the negative direction? Negative infinity. So that's where it starts. And then where does it stop? Where does it end? What's the biggest number in the positive direction? Positive infinity. Okay? Now, do you remember us doing intervals? All right, before we had to do parentheses, or sometimes we did squared off brackets. That's coming back. Okay? Now, for set notation, all we're going to do is turn that thing into an inequality. An inequality. But you have to tell me that it's the x's. So we're going to make it fancy. We're just going to put x in a bar, because that's just telling you what variable to use. Now, if I started one number and ended another number, then x represents everything in between. All right? Have you seen the notation where x is in between less than symbols and two numbers before? Have we done that before? Yes. Okay? And they're always less than symbols because the smaller number always comes before the bigger number. All right, so this is interval notation and set notation for the same domain. They mean the same thing. Okay? You still with me? It takes practice. This is new for a lot of you. All right? Now, for the range, remember what we said earlier is that you read the graph from bottom to top. Okay? Now, when I look at my actual graph, all right, and I say, does it, like, how far down does it go? All right, and it's good. It's got to be a y value. So it never goes below the y value of -2. Perfect. Okay? So when you do the range, you start at the lowest value the graph ever touches, and you work your way up. Okay? Well, let's talk about what the ends are doing. Yes, we said they're going out, but they're also going up forever. What is up there? What number is the biggest number you can go up to? Positive infinity. And if I had to go down, I could eventually get down to negative infinity. So when I do my range, where do I start? What's the lowest y value that's on this graph? -2. And where do I go up to? Positive infinity. Now, this is where we come back with our parentheses and brackets and all that stuff. Do you remember us saying that infinity always just got a parenthesis? All right. When does a number, like, and we did it on number lines, but when did a number get a squared off bracket? When it was what kind of point? Open or closed? Closed. Okay. Well, do you see an open hole on that point right there? No, it's filled in. Okay. So that is essentially a closed point. So that is going to get a bracket, a squared off bracket. Okay? So now we need to come up with an inequality that would go with that. Okay? And you have to tell me that we're using the y values because this is the range. All right, well, where does my interval start? -2. So that's going to be your first number. And then you're going to do a less than symbol. But with a squared off bracket, what else are you going to put with that less than symbol? Well, yeah, that's going to go here, but what do I, like, it can't be just a regular less than. It has to have the equal to part on it. That's what matches up with the squared off bracket. And then infinity is a parenthesis, so that's just going to be a regular less than. And then infinity. Okay, I know that's a lot. All right, so let that sink in for a minute. In your notes, okay, to remember the whole idea of closed brackets and parentheses and stuff. So if you'll please remember that closed points, all right, closed points get square brackets, and they match up to the inequalities that have the equal to. Closed points get square brackets, and that matches up to inequalities that have the equal to part. And open circles and infinity get parentheses, and that matches up to regular inequalities without the equals bars. Now we're going to look at some graphs that I'm going to give you the graph, just like I did on that, but it's going to be in pieces, which means it's technically a piecewise function. But I'm going to give you the graph, all right, and then we're going to try to figure out the domain and range, all right? So you can call this number 4. And for those of you watching this video, I'm going to pause it while I actually draw the graph. All right, so let's take a look at our domain. Remember, you have to read the graph from left to right and see what x values the graph actually touches. Okay? So when I start on the left of my graph, it's an arrow. Yes? And yeah, I know it's pointing down, but it's also pointing to the left forever. What number is out there? Negative infinity. That means our first piece starts at negative infinity. Okay? So that's going to be our first piece of our interval. And then as I trace my graph towards the right, I get to a closed point at -1. Now, don't write that down yet, because now I need to see what happens after -1. All right, to see if I actually need to stop my interval or can I keep going. Okay? Now, right now, this would be a closed, right, bracket on -1. But then my graph jumps down to -1 down here. All right, well, is -1 included? Am I allowed to equal -1 in at least one of those pieces? Is one of them closed? Yes. Okay, so we get to include -1, but then this graph keeps going to the right, directly after -1. So I don't have to stop at -1 if I'm allowed to equal it, and then I pick back up and keep going to the right. Okay? So I'm still going to the right, and I haven't had to skip any numbers. All right? This one covers everything up to -1, including equaling -1. And then this one picks right back up and keeps going to the right until I get to 4. All right, and I'm allowed to equal 4 right here. But then if I go up to the next graph, it starts at 4, even though it's not allowed to equal, and keeps going to the right forever. So I have actually covered, I've actually touched every single x value that I could possibly touch from negative infinity all the way to positive infinity. I have actually touched every single x value. And somewhere there was a closed circle, even if there was a break in the graph. Okay? So then the set notation for that, we've done that one before. All right? You just put your x, and then you start at negative infinity, less than x, less than positive infinity. All right, so for the range, you're going to work your way from bottom to top. All right? But even though it's hard to see, you have to remember that if there's an arrow that's pointing down, all right, it's actually lower than any points that you have anywhere else. Right? So it's still pointing down to what number? What's the lowest number this part of the graph will ever touch? Negative infinity. So that one's going to start at negative infinity. And I'm going to work my way up. And I'm just kind of looking to see if I kind of head up, is there a piece of a graph that's always touching a y value? Okay? Well, this piece touches lots of y values as I go up. This piece touches lots of y values as I go up. All right? But there's a break right here where there's no y values being touched. Are you with me? There's a gap between a y value of 3 and a y value of 4. There's no graph. There's no black connected line. So that means my range actually has to stop at 3. All right? Now, since the point 43 is closed, what kind of bracket or parenthesis do you think I should put on the 3? Square bracket or parenthesis, since the point is closed. Square. Okay? Now, where does the next graph pick back up? The y value. 4. So we're going to do this thing called union. We've done unions before. And we're going to pick back up at 4. But that point is open. So what do you think I put with it? Parenthesis or squared off bracket? Parenthesis. And then what happens with the rest of the graph? It continues to go up forever to what y value? Infinity. All right, and infinity always gets a parenthesis. So there's my range. We cover almost everything from negative infinity to positive infinity, but there's one little gap from 3 to 4 that we don't cover. So this is how we show that. Okay? All right, now all I have to do is turn that into sets. All right? So it's one big set, but if I have 2 pieces, all right, in my range, I'm going to have 2 inequalities in my set. All right? So I still have to tell me what letter. Don't forget it's the y's. And I'm just looking at the intervals. The first one starts at negative infinity, and then I put y in the middle, and then it ends at 3. But 3 has a square bracket, so I'm going to put an or equal to on that inequality. Well, then I have another one, so I got to use the word or. All right, and the next one starts at 4 and works its way to positive infinity. Do I put any equals with those? No. Questions? All right, so we're going to do another one. And like I said, I'm going to draw the picture for you, and then we will look at it. So, for my domain, all right, I'm coming from left to right. Do I have an arrow this time pointing to the left forever? No, I do not. Okay, so what is the first x value that I get to that actually has a graph on it. The first x value, -3. So that means my first interval is going to start at -3 for a change. Now, is that circle open or closed? Closed, which means I'm going to put a parenthesis or a square bracket on it. Square. Okay? Now, as I trace my graph to the left from -3, the next x value I get to that has something going on is -1. Now, does the rest of the graph pick back up with the same x value? No, it does not. So that means I actually have to stop my interval at that x value. Now, is it an open or closed circle? Closed, so it also gets a square bracket. But then there's a whole other piece to the graph that picks up at what x value? 1. So that means we need another interval that starts at 1, and it's closed, so it gets a bracket. And then as I work my way to the right, what's the next x value that has something happening? 4. And the graph just stops, and there's no more graph. So we have to stop our interval at 4. But it's an open circle. So it's going to get a parenthesis. Very good. So this one's very different than the other ones we've done. There's no arrows whatsoever, and the two graphs have no numbers in common, so we actually have to break and pick back up somewhere else. Okay? All right, so now we just need to figure out what the what the set notation would look like for that. How many sets, or how many inequalities are we going to have in our set? Like how many different things, since we have two intervals? Well, we're going to have 4 inequality signs, but like in terms of like parts, there's going to be 2 parts, right? The first one's going to start at -3, all right? And I'm going to use a less than or equal to sign, because it's a square bracket. X goes in the middle. I'm going to use another less than or equal to sign, and I'm going to stop that one at -1. So that's one big chunk. And I'm going to say or, and I'm going to start the second one at 1 with another less than or equal to sign and an X. But when I go to the 4, I need to just use a regular less than, because that's a parenthesis. So you have to make sure that you're matching up your square brackets with your inequalities with its equals, and your parentheses with inequalities that don't have equals. All right, that's just 2 different ways to write the same domain. All right, now let's start with the range. All right, so again, none of our pieces have arrows. So does this thing start way down at -infinity? No, it does not. What is the first y value that we get to? -4. Okay? Go away. Okay. -4. Does it have an open circle or a closed circle on it? Closed. So we're going to put a square bracket. Now, as we go up, this graph covers all the y values and some more that this graph covers. Well, I don't have to write them twice. They cover the same y values, yes? So this one over here does not really have a different impact on my range. It covers the same y values as the other piece. But the other piece covers more. All right, it goes all the way up to what y value? 3. Open circle or closed? So it gets a parenthesis. Does either one of those graphs cover any more y values? No. So that is it for the range. All right, so now all I need is my set notation. I'm just going to have one thing that I have to take care of. I have to start at -4. I'm going to use a less than or equal to, and then the y, and then a regular less than, and the 3. Does everybody understand when to use the equal and when not to use the equal? Questions? Man, we got some sleepy heads in here today. All right, I'm going to draw one more graph and give you a few minutes to try it completely on your own. All right, before we take a break. All right, so here's my graph, and I want you to see if you can figure out the domain and range. All right, so for those watching the video, I know you can't see what I'm doing, but what I like to do for domain is I basically like to run my finger from left to right and trace the graph. Whoa, I don't want it to move. Sorry, turn the pen back on. Here we go. All right, so I trace the graph from left to right, but I look at the left and it's an arrow pointing where for the left? Not down, but left. Where is that arrow pointing? -infinity. So my first interval for my domain has to start at -infinity. Now I trace the graph to the left, and I get to an x value of -1. And then, but when I jump to the next piece of the graph, do I start back over at -1? No, which means my graph actually stops at -1, so my interval has to stop at -1. All right, parenthesis or square bracket. Square, okay? Then, as I work my way to the right, the next thing about the graph that I get to is this point right here. Okay, so how do you think you do an interval for just one point? Where does it start? Where does it stop? What x value? 0. It starts and stops at 0. So you literally just put the one number, and it's in square brackets. All right? And then there's another jump to what x value? What's the next x value the graph starts at? 1, except it's an open circle. So we need a parenthesis. And then if we keep tracing it to the right, we eventually go to the right forever. So what's my last piece? Infinity. Okay? So now when we go to write the set, oh my goodness, there's 3 parts to it. All right, so I gotta make sure I give myself plenty of room here. All right, make sure you tell me that it's the x's. All right, and the first one starts at -infinity. X is always in the middle. And then it stops at -1. But we need an equal to on that because it's a square bracket. Now, for the ones that only have one number in them, for those, you literally just tell me x equals that one number, and that's all you can do for that. Okay? And then we move on to the last one that starts at 1. Put your x in the middle with your less thans. All right, do any of those less thans need an equal to? All right, so that's my set, my crazy set notation for this graph, for the domain. All right, now the range is actually a lot nicer All right, it looks like it might be more complicated, but it's not. All right, so I look at my graph, and I do see an arrow pointing down forever. So I'm going to have to start at what? When I go from bottom to top? Negative infinity. All right, now if I trace that graph, I stop at 2. But the other graph, forget about the point for a minute, the other graph starts lower than 2 and keeps going up past 2. So are all the y values in between here covered? Even though they're on 2 different graphs, are they all covered? Yes. They even cover the same, they even double up on this y value and triple up. Like they all touch that same y value. So I don't have to skip any of those because at least one part of the graph is touching everything in between. Are you with me? So then all I have to do is look at the end here, and where is it going? Up to positive infinity. So even though the graph has all these crazy things going on, I actually do touch every single y value as I'm going up on at least one of the graphs. Sometimes 2 of the graphs, or even 3, touch that same y value. Okay? And so then the interval for that, or the set, is super quick and easy. Just make sure you use the right letter. Okay?